right, now that we've disconnected it from the base, we can start taking a look at the inner workings of the boiling cauldron. So the first thing I'm going to do is remove the outer shell. And I don't have it attached with anything. There aren't any dowels or anything like that. There is, on the inside, you can see a square that fits around this portion of the motor. Here's a 3D representation of the top portion of the shell. As I turn it over, you can see the square portion which fits over the top of the engine and leaves enough room for the squares to move up and down. However, when you flip it over and look at it from the top, it makes that square set of tiles appear round. Here is a video clip from March of 2024 when I was making sure the top portion of the shell would actually fit and allow the square tiles to move freely. It clearly shows the fit of the square hull and how it changes the look from square to round. So the engine itself is divided up into two parts, a lower part and an upper part, and each does pretty much the same thing. Taking a look at it from the side, you can see that the lower level has 4 camshafts and the upper level has 3 camshafts. There's a gear for each one of the camshafts, and you can see how easily that turns. Each of the camshafts are supported on each side or each end of the camshaft by skateboard bearings. Those skateboard bearings really smooth out the movement. When I was first doing development on this, I started out with just having the dowels inserted into holes in the wood, and there was just a lot of friction there. They didn't turn very smoothly. So that's when I switched over to the skateboard ball bearings, and it just made a world of difference. A lot less strain on the DC motor that's attached to this. One other thing that I'd like to point out before we start pulling this apart is that the gears on the ends of each of the camshafts are slightly different sizes from each other. And the reason for that is it introduces a level of variability as the pistons are being moved up and down by the camshafts. I didn't want them to have the exact same pattern every single time. I thought that would be a little bit boring. I like the random pattern better. Originally, I called this the walking carpet because it was, square, rectangular, and it reminded me of the tiles of a floor, and they're moving around. So walking carpet, that's how I talked about it for quite a long time until really the project was almost finished. I had some friends over to come see the marble machine in action, and one of them was talking about this particular component, and they referred to it as the boiling cauldron. And I thought, that is a much more appropriate thing to call it, because when you have the shell on, it looks like you have like it's molten lava that's bubbling. So I think boiling cauldron is a much more appropriate name for it. Sometimes I still call it the walking carpet. I use those names interchangeably, but I do think boiling cauldron is a much more apt name for it. There are, as I mentioned, a total of 7 camshafts. Now, you may be familiar with what a camshaft is, you may not. I have a larger camshaft here. This is very similar to what I have in the motor for the boiling cauldron. The camshafts inside the motor, each camshaft has 7 cams. This only has 4. I cut out 4 discs out of 3/4 inch plywood, and then I drilled holes in it, and they're off center. You can kind of see that. You start out with all of them having pretty much the same. We'll do that. If you start out with all of them being in the same relationship with each other on the shaft, there's no real interest there. They move up, they move down, they move up, they move down. And the pistons are resting on top of those cams. And so as the cams move up, the piston moves up. As the cam moves down, the piston moves down. Well, this is kind of useful, but it's really a boring movement. So each of the camshafts, the cams are turned a little bit in relationship to each other so that it gives a wave-like motion. So you can see if there's a piston sitting on top of this and a piston next to it and next to that, that they are going to be moving up and down in a wave-like motion. Now, the reason I'm spending so much time on the camshaft is that It was one of the primary design considerations for why I made this into 2 levels instead of trying to make it all 1 level. Let me show you what I'm talking about. So first of all, I'm going to take the top off of this, and the top is attached to the bottom with just some 1/4-inch dowels, 4 1/4-inch dowels. There we go. Top comes off. I'm going to set it to the side for just a minute, and you can see, you can tell very, very quickly which are the longer pistons and which are the shorter pistons. What I want to show you here, turn this over. The reason I made this 2 levels was that it would have been very, very difficult, especially with the skateboard bearings. It would have been very, very difficult to fit 7 in this limited amount of space. I think I could have done it, but it would have made it a lot more difficult to put together. And I think I would have had to reduce the size of these individual cams. And if I had reduced the diameter of the cams, I wouldn't have had as much movement as I wanted to see. It made more sense just to split it out into 2. If I wanted to keep it all 1 level, realistically, I would have had to increase the size of the squares on here. It would have increased the size of this component. See, right now, the squares are just about the size of the ball bearings that I'm using. If they were larger, I wouldn't have gotten the movement that I wanted. They wouldn't have had that same quickness of movement and the erratic behavior that I was looking for with larger squares. So instead of having it larger, 1 level larger, to get the number of pistons that I wanted and the number of camshafts that I wanted, I went vertically instead of horizontally. So that's why there's 2 levels. This is one of the pieces that I cut out on my CNC. This was a double-sided job. Little design consideration on this. The hole for the piston, it's not the same diameter all the way through. Why didn't I just keep the same diameter all the way through? The reason is friction. I wanted to reduce friction as much as possible with only about 1/8 of an inch of wood pressing against the piston. That's a lot less friction than if it was the entire height of this piece. In my initial design of the piston board, I made the holes for the dowels the same thickness all the way through. The problem this caused was that the motor had to work harder to move the pistons up and down because of the friction between the dowels and the sides of the holes. To solve this, I cut a pocket on the back side of each hole, which helped reduce the contact and therefore the friction between the dowel and the sides of the holes. By the way, these are made out of beech wood, very stable wood, wonderful to work with. People have asked me, well, where do you get the wood for your projects? I have a few different sources of wood. I'll talk about one particularly special one here in a minute, but I keep an eye on Facebook Marketplace. I keep an eye on people who are getting rid of wood from trees. And so a lot of times I'll go get some reclaimed wood. I've got quite a bit of walnut wood out back and some cherry wood out back that I've done that with, and I'll process those and use them in my projects. The other place that I go to get wood is a local place called High Desert Hardwoods. It's over in Eagle, Idaho. They're not sponsoring me. I'm not an affiliate or anything like that. I've known them for years. They're fantastic people to work with. They've got really a great variety of different hardwoods. And it's always been a pleasant and great experience going down there and talking with them. And so if you're in the area, I would just encourage you to go by there and say hello. And again, I'm not affiliated with them in any way. I just think they're a great business and that you should support local businesses when you can. The piston part of it is just a simple dowel. The square cube part, rectangular part, it's not quite a cube, but I cut these out on the CNC. And when I cut them out, you've got the hole there for the dowel, and then the top was just flat. And that actually caused a problem because when the ball bearings were sitting on top of a flat surface, a lot of times they would just get stuck there. There wasn't any reason for them to move away from the center of that square. So what I did was I sanded these into a curved surface, curving down to the 4 corners of the square. And so when there's a ball bearing on the piston and it pushes up, that happens. The ball bearing rolls off a lot more easily. One other note in regards to these, the wood I used, this is apricot wood. A friend of mine named Don had I forget whether it was his mother or his grandmother, had a large apricot tree. It ended up dying, And so they had to cut it out, and he knew I was a woodworker and brought me some of the wood. And so Don, just thank you for the apricot wood. It is a pleasure to work with. It has a beautiful grain. It is naturally a little bit orangish in color. And when you work it, the dust smells a little bit like you're baking an apricot or a peach pie. And I've ran into that a few times with fruit woods, with cherry. You'll get this, the wood shop fills with this aroma of baking pie. At least that's what it reminds me of. So it's fun to work with and just beautiful. I use the apricot wood for this and also for a few other places on the marble run. So again, thank you, Don. The other wood that I'm using here is walnut. And here's another note on the pistons. And also on this right here, you may have noticed that there's a notch in each one of the holes that the pistons fit into. And the reason that is there is because when I was testing this, the movement of the camshaft was causing the pistons to turn a little bit. And I didn't want that. I wanted them square with each other. So what I did was I made some very tiny dowels. I cut up pieces of toothpick and glued them onto the pistons. And then that little notch fits into, that little dowel fits into that notch on this grid. And it helps prevent the squares from twisting. And not every single one of the pistons has that little dowel on it. Didn't need to be on all of them. It only needed to be on a certain subset of them to help keep everything straight. So that's what that notch is for, if you were wondering. Okay, so that is the bottom layer. Let's go ahead and look at the top layer. We'll move this over here. So what I'm going to do is pull out the pistons so I can turn this upside down. I could leave them in here and turn it upside down and they would go everywhere, but that's no fun for anybody. So I'm going to go ahead and go into my super speed mode and remove the pistons. Whew! Makes you thirsty. All right, so this is level 2, or the upper level. And as you can see, pretty obvious, there's only 3 camshafts here. By the way, the camshafts, the little cams on there, those are all made out of maple. It's a hardwood. There are a lot of hardwoods, and some hardwoods are harder than other hardwoods. And maple is generally one of the harder hardwoods. And so for this in particular, where I had moving parts rubbing up against each other, I wanted one of the harder hardwoods. And so that's why I used maple. These were, the little cams were cut out on my CNC. And you can see where I probably had the speed a little bit off on there because it burned a little bit when it was cutting it out. But didn't really matter a whole lot because generally no one sees this unless you're watching this video. So it doesn't really matter that there's some burn marks on those. And then one thing to point out is that they are not in perfect sequence with each other. And again, that's by design. I wanted to introduce that variability into it. So it's not random, but it's variable enough that it might as well be random. And the reason that I did that was because I didn't want the ball bearings moving along the top the same way every single time. And so that variability gives what I wanted from a visual interest perspective. Okay, now we're almost ready to put the shell back on, but before I do, I want to show you how the motor attaches. So I have this DC 12-volt motor, 25 RPM. It is the same motor that powers the magnetic lift as well as the auger lift on the marble run. And I'll include a link to this motor in case you're interested in it. This is one of the spares that I had. I've got it hooked up to my 12-volt battery here, and I'm just going to fit this into the drive shaft. There we go, and turn it on. And if I put a ball bearing on there, it'll immediately fall down into a section that I need to pull it out of. There we go. Get that going again. Oh, and there it goes. All right, but you can see the motion of the camshafts as they're moving the pistons up and down to create that wave motion. So I want to go ahead and attach the shell, but before I do that, I'd like to talk a little bit about the shell. I'm going to go ahead and turn this off for now. Let's pull the motor out. I'm going to move this to the side and grab the shell. So the shell is made up mainly of cherry wood and walnut wood with a few other woods just for contrast. I left this section open. This one section is the section that shows off the gears. And again, I'm looking for visual interest, which is why that's open. In my original design, I was going to have robots, a few different robots, perhaps 4 or 5, doing different things. Their arms might be moving and waving, or they might be picking something up, or they might be pushing a ball bearing into a different location. And as interested as I was in doing that for this project, I simply ran out of time. I had to have the marble run complete in order to get it into the Western Idaho Fair by a certain day, and there just simply wasn't time to go through the rest of the process of design and creation of the robots and testing and implementation. So for this particular piece, the shell of the Boiling Cauldron, I had originally planned that this section right here would be a platform where a robot would be standing on, and he would be surrounded by like a desk or a control station, and there would be buttons he might push or levers that he might pull. So that was the original plan for this section right here. And again, I just simply didn't have time to implement that. So I was looking for an alternative, and on my shelf I had this wood rocket that I had built maybe 1.5 years, possibly 2 years ago, and I just had it on a display stand, and I thought, aha, that is something that would go very well with the overall theme of this project. It's really made out of some of the same woods that I'm using, and so why not put it here? I don't have time to work with a robot. One of the things that I had to do was I had to drill out the fuselage and then drill down pretty deeply into the rocket so that I could run the wires for the LEDs into it. I also had to drill a hole on the bottom so that I could put this walnut piece there. That's where the electrical wires all come down to and are fed by the wires down below. And adding the LED lights to it also was a pretty major change. So you can see in the back the fuselage there. I have a couple of LED lights that are embedded in epoxy, and then I've got the front light. It's a special light. It's a special blue light, or a blue light special. And then I've got the red lights there on the bottom. And one of the things that I discovered, and I discovered it for myself, I'm certain other people knew about this, but it was new to me because I hadn't really worked with LEDs much before this. But when you embed an LED light into epoxy, it diffuses that light and it gives kind of a nice glow. And I use that here in the fuselage, and I use that in other places on the marble machine for different effects. And let's go ahead and put our shell back on. And before I do, a little commercial break here. If you are enjoying this content, if you are enjoying these videos, if you would like me to make more of them, then I certainly would appreciate, if you haven't already, if you would subscribe to my channel. It really helps a lot. It gives me the potential opportunity to spend more time working on projects like this and bringing this kind of content to you. All right, moving on, let's go ahead and reconnect, or we're not really reconnecting the shell. We are just putting it back on top of our boiling cauldron. Here we go. voila. And let's hook up our 12-volt motor. There we go. Hook up the power. And voila, there it goes. I'm going to go ahead and put the exit ramp back on like that. And not necessarily simple to do. We're doing it like this. Oh, that fell off. It's still running. We'll probably be okay. All right, there you go. And I got a ball bearing right here. This is where they come in. And you can see the behavior of the ball bearing there on the Boiling Cauldron, and it's going to move it around, and the wave motion is coming this direction, and it's fine if it bounces around quite a bit. When I'm running the entire marble machine, there can be 20 or 30 ball bearings in this section. You can hear the load on the motor when there's that many ball bearings in it, but it hasn't pooped out on me yet. And so, but yeah, this should shoot it around, and even if it looks like it gets stuck at a certain part here, the variability of the speed and of the gears and the camshaft should cause that ball bearing to move away from that particular location eventually. Now, of course, there's other factors involved, which are, this bench isn't necessarily level. Gravity might be pulling it towards that edge and not allowing it to release, but we'll just give it a minute and see if it actually works its way out of there. I have confidence that it will. That did it. I looked away for a moment and it came out of there, so. All right, now all that's really left is for me to go and reattach this back onto the main base. If you have any questions about how I did anything on this particular piece or any of the other parts of the massive marble machine from outer space, I would love to hear from you. Go ahead and put in a comment, ask a question. I'll get back to you as soon as I can. And depending on the nature of the question, it might turn into another video.